Hello, everyone. My name is Will. Today, I'm really happy my good friend and fellow Kyma user Simon Hutchinson is here with me, and we're going to do
Thanks for having me.
absolutely no. Thank you for being here. We're going to do a talk through tutorial of the SumOfSines here in Kyma. So I've actually already launched it. It's right here in the additive synthesis category of the prototype strip. And essentially what we're going to do is our own spectral analyses of two samples. So we're going to start from one sample and morph to the other one. And right now we have this Balinese gamelan. I'll spare us listening to that for now. But the main point here is that we can see it's in both of these positions, analysis 0 and analysis 1. So what we want to do is get
So,
two. Yeah, sorry. Go
what
ahead,
I'm going
Sam.
to interrupt you. What does SumOfSines do?
Okay, so the SumOfSines is an additive synthesis prototype that works off of spectral analysis, where we extract frequency and amplitude envelopes of a sound, and then that information, controlled information, drives individual sine wave oscillators that when they're added back together, if we've done a quality job, uh, sounds like the original sound. It's how
I
I
love
would
it.
would say it simply. I don't know if that you agree with that.
I think that's great. Yeah, I mean it's additive synthesis, right? As we know, all sounds are made out of can be broken down into sine waves that get added together at different frequencies, amplitudes, and phases, and then we can reconstruct any sound. Yeah, just as you say, we're going to look at breaking down some sounds and then putting them back together with the sum of sines.
Exactly, and because we have them in that state, they're much more flexible. So we can operate on just the frequency aspect or just the timing aspect. Where if it's just a
Right.
sample, we only have control over the rate of which we read through those samples. So the first bit here is to do an analysis, and this is one thing I chose before doing this tutorial. I'm going to use samples right in the Kyma library in case people at home want to recreate this themselves. So right in Kyma 7 folder, samples, speech. Actually, what am I doing? I need to go to tools, spectral analysis.
Oh yeah.
There we go. I'm like trying to choose the analysis before I've even done it.
Is
So
there a key command for that? Is it Apple something? I can't remember.
command 1.
Command one. Okay.
Command 1, yep. All right, so here we go. So following that same path, Kyma 7 folder, samples, speech, C morph. Here we go.
Morphing. Morphing.
And this is looping, and it's saying set the
Morphing.
time between repetitions.
Morphing.
So we hear it slightly less often.
Morphing.
I'm just going to choose 2.
Morphing.
Whoops. Cool. And now we can basically experimentally arrive at the best setting. So Kyma will coach us through this, but what I like to do, this is one area where you really can just kind of click buttons, use an educated guess. And so
Morphing.
right now we can
Morphing.
hear the resynthesis. I'm going to pull up
Morphing.
my DSP status too, because I
Morphing.
can see that this is pretty hot, so I've got control over the
Morphing.
level.
Morphing.
So right now we're not hearing the sample anymore. We're hearing a real-time
Morphing.
analysis of the sample and 252 sine waves
Morphing.
recreating it, right?
Morphing. Morphing.
That sounds a little better to me. I don't know about you,
Morphing.
Simon.
Yeah, I think that's a little. So
Morphing.
I think here about the frequencies, right? And so it's a
Morphing.
little bit small, I know, but it's
Morphing.
above these different frequencies, right? So above 22 hertz, that's like the very bottom of human hearing.
Totally.
So you might not have to go down there for something that's vocal, right? I think it was getting better at that 173. I mean, we could keep going up and see if we end up losing those low frequencies as we go up too.
That's exactly what I do. So let's check that out.
Morphing.
Yeah, we've lost some low frequencies there, huh?
Definitely.
Morphing. morphing,
These are close, but I think 3F is the right
morphing,
choice.
morphing,
And then for frequency and timing, there's no real, if
morphing,
this was a rhythmic loop or something, I would be more concerned about
morphing,
the timing. But since it's not, I'm
morphing,
more concerned about getting the best frequency.
morphing, 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 morphing,
That sounds about right to me.
Sounds good.
morphing,
Cool. So now we can see that this is
morphing,
124 individual sine waves for this resynthesis. I'll
morphing,
click next. And one thing I'm going to do, we could get a spectrum file right away from this, but in the book, as I was brushing up on this, it teaches us that speech is at least quasi harmonic during the vowel parts. So let's go ahead and do this one additional step so we can really hone in on this
morphing,
analysis. So now I'm basically going to move this fader until
morphing,
we only hear attacks, noisy
morphing,
segments of the sound.
It's like the consonants
morphing,
in this voice.
Right.
morphing, morphing,
It's somewhere right in there, I think. We
morphing,
don't hear the vowels, but we hear still hear some noisy stuff. Let's
morphing.
try that. Kyma thinks for a second. Great. So here's the spectrum of the sound. We can listen to the original sample.
morphing,
Only the fundamental, which is down here where this
morphing,
line is, white line, or all the harmonics.
morphing, morphing,
And we can see that Kyma's done a really nice job of
morphing,
tracing the fundamentals. So I don't think we need to make
morphing,
any changes. But if I zoom
I think
in,
it's having. It looks like. Oh,
morphing,
yeah.
did you see a
I was just
section
gonna say
there?
it looks like it's having more trouble with
morphing,
the F. I think it's fine. I don't think you need to change anything, but it's interesting to
morphing,
see that F is where it has the most trouble because the F is
morphing,
sort of a noise sound, like
Mm-hmm.
morphing,
whereas like more, we can
The vowel.
determine a pitch for
morphing,
those. Yeah, those vowel sounds.
I'm just zooming in on a few areas to see if
morphing,
it jumped up at all. It looks like it stayed on
morphing,
this first oscillator, though. So that's
morphing,
cool. Let's push on
mor-
with this, and now I can create the quasi-harmonic spectrum file. Please enter the bass pitch for this analysis. It tells us first pitch 55.7, but we see use 60 note number if this sample has no real pitch. I would say that this falls into that category. I don't know if you agree with that, but I don't hear a...
I think I agree. I mean, I would say it depends on how you're going to use it, but
Right.
but I think absolutely if we're just taking it as speech, I think that's a good idea.
Perfect. I'm just going to put this into my Spectra folder, call it tutorial CMorph H for harmonic, and then I should add SPC for spectrum. Great. Kyma makes this
morphing,
file. Here we are. And so now we can see all the individual sine waves that are contributing to this sound, and I can listen to them individually. So if
I know on my screen it's a little dark, but I mean if I don't think there's anything you can do, but we can certainly see the greens on the bottom and how it gets sort of to a purplish and lighter purplish at the top there.
Right. So I guess the main thing here is at the bottom we have lower frequencies, at the top higher frequencies. If I hover my mouse, we can see that I'm currently over track 3, which would be the third partial, the third oscillator in the resynthesis at a frequency of 563.6. As we go up, we see higher track numbers, higher frequencies. Cool. So that's the basic process. We're done with that one now. Let's go back and do our next one, our kind of destination where we're going to go to with this sound.
And these aren't just, one thing to think about is these aren't just used for SumOfSines, right? We can, once we have these spectrums, there's a bunch of different Kyma sounds that use these, and different
Exactly.
ways to implement them too.
Exactly. Back in our Kyma folder, we go to samples, and it's in clicky sounds. I had decided a sticky plastic tube fast. And if you're wondering how I decided on these samples, that too is an experimental thing. You basically, I wanted them to be similar enough that we could pull off or a somewhat convincing morph quickly, different enough that it would be interesting to do that, because if it's so similar, then you don't even really hear it. And basically through trial and error, I found this does a pretty cool job. So I would basically say it's experimental. I don't know if you've had that experience as well.
I have to admit, I don't use SumOfSines for the morph a whole lot. I use SumOfSines a lot, and we were talking before we did this about how it's a really good thing to get sunk into when you're getting started in Kyma, whether you have experience in other synthesis or not. You did sample clouds last week,
Right.
right?
Totally.
And so those sample clouds and SumOfSines are really good ways to show what Kyma can do. That's kind of harder to do in other softwares. And so, this fact that we need, we're making sounds that we're going to use 120 oscillators to recreate. That's not a trivial thing to build, either physically or in other software environments. Although, there are a number of things that still use them.
Yeah, that's exactly right. I feel like it's more deliberate, and there's a finer level of control, less compromising
Absolutely,
on the
yeah.
sound quality. Okay, I suspect a lot of these settings are going to be the same, but let's arrive at our resynthesis here. Definitely think that's too low. It's getting better. What do you think? 2F or 3F?
So I mean, I'm listening to the audio stream, so
Sure.
I'm getting some filtering too, but I think it's a noisier sound, and so it's going to be a little bit more forgiving than the voice too.
Yeah, that's right. I think we'll roll with 3F, but you're right. It probably is more forgiving.
That sounds good to me.
Right. And if we go back to the original. Now the resynthesis. Yeah, I'm feeling pretty good about that. So we have best frequency and better frequency tracking. Next, same deal here. Set quasi-harmonic parameters. This is really subjective.
This is interesting because I don't usually set these quasi-harmonic parameters, and so I'm learning some things as I watch you do this.
Yeah, I think it's just about going one step further and being able to trace the fundamental. I think it's also interesting here when you're not dealing with a clear tone where you can say, okay, that is clearly the first pitch, and then, this is more noisy, and so it's interesting.
I think it's related probably to the fact that you're using that morph more than I do too, because I don't know. I mean, if I'm just using SumOfSines for additive synthesis, right, to break down sounds and then be able to adjust pitch and time independently from each other, maybe this step isn't quite as important as when you're trying to do that morph between multiple files. I don't know the answer to that.
No, it's good. I don't think we had to do it here, but I just wanted to. So the original sample, fundamental only.
You can really see those harmonics
in
this one. I'm kind of impressed. I thought it was a noisier sound.
And if I zoom in, we can see it's, definitely noisier. Just check a few more areas. Might have lost and gone up here, so I can just kind of drag this down. Just cleaning up slightly. Right, we could get super meticulous and go in there, but I think this is pretty good. Let's move on and create this quasi-harmonic spectrum file. Same thing here. I'm going to set this to 60 note number because it doesn't have any real pitch. We'll do the same thing. Tutorial. Sticky fast tube. Sticky plastic tube fast h.spc. I'll put it in my Spectra folder. All right, we're almost to the fun part.
This wasn't the fun part?
All right.
I mean, that's all being made up of sine waves.
Yeah,
That's amazing, right?
it's super cool.
How many sine waves do we have? I wasn't paying attention for that second one. The first one we had 124, right? How many do we end up for?
I believe
this one?
this one's the same. I'll load them both in here and then I'll show you.
Great.
So,
Sorry, I'm just getting excited about how many sine waves are going to be playing at a time here.
there we go. So I just loaded the first vocal morphing into the first spot, and then I'm going to do this one into here. If I shift click on this disc button, we can see 124 partials in the first one, sine waves.
Yep.
We should say up to that amount. We don't have to do that many, and if we do more,
Right.
they're not going to be there. And 124 here as well. All right, cool.
And some of these analyses will end up with more, like 256 and stuff like that. Those settings that you set when we're choosing for the resynthesis, that determines that to a certain extent.
Totally. Cool. So let's just hear what we've got right now. Loaded in. If I go to dB morph and pitch morph, both at 0, that's this area here, we're hearing the morphing. If I take them both to 1, we're now hearing the plastic tube, right? Somewhere in between.
So why are they slower?
Yeah, because right now...
I'm going to interrupt you, sorry.
No, it's totally right. Because we're now reading through them here in this on duration field, 4 seconds times 2 minus rate, and our rate fader was at 1. So we're reading through this in 4 seconds, but its length is 1.3335 seconds. So it's about 3 times as long to go through it at this rate. So that's, again, we can shorten it, or we can make it even longer. So if we're hearing it get even longer. When this is 0 now, rate's 0, 2 minus 0, we're now 8 seconds to read through this, right?
So, I mean, I said this sort of briefly before, but I love this ability to independently control the pitch and the length, right? So normally if you stretch out a sample, the pitch gets lower and lower as you stretch it out.
Totally.
And I was talking to Will before this. One of my favorite things to do is just go, if you'll humor me for a second, Will, can you go to that on duration and put like 120 seconds in there?
Yeah.
And then we can morph it all the way one way or the other. And now morphing is going to happen over the course of 120 seconds of 2 minutes. We don't have to listen to the whole
We
thing.
don't have to. I was going to. I'm glad you stopped me.
It can be a great way to sort of generate backgrounds, generate ambient sounds for a really long time. Again, so the morphing is more pitched. If we went to that tube, which is a little bit noisier, so if we morphed all the way the other way, we might have this sort of ambient texture that we could stretch out.
Totally.
Again, maintaining the pitch.
Let's hear that.
That's not what I expected.
That's pretty crazy.
That's great, but yeah, that sounds good too.
You never know, right? I mean, taking 2 minutes to read through something that's only 2 seconds, it's going to go through a pretty gnarly transformation, I would think.
But getting back to that, you never know. I mean, that's the fun about doing this experimentation is we're using samples that people haven't done this stuff to before. If you're using your own samples, you've got this musical material that no one's ever touched or stretched a million times before. And that's the sort of exciting thing about instant customization of of your musical sound.
Yeah, true. Okay.
Anyway, sorry, I totally derailed what you were trying to do.
Not at all. It was great. So one thing I just want to
talk about what I want to do, right? Yeah.
I can learn this fader here. I've got my KORG nano controller here, so I can kind of perform the morph a little bit with the faders. Before I was just using my mouse. So now I've learned dB morph and pitch morph to the same fader, so we can simultaneously morph those envelopes. So
that's just a KORG nano control, whatever they're called, a MIDI control, and you've learned the MIDI sliders there.
Yeah, if you just control click learn, and then whichever CC you want, you just plug and play as far as that goes. So now, check it out. I'm going to go put this back a little shorter, Simon. I'm sorry.
Oh.
Let's just say 2 seconds for now.
Morphing. Morph.
Right, and we're now going from one sound to the other much quicker, and it sounds pretty good, I think.
Morphing. Morphing.
But it's right now it's contingent on me doing a nice job there, kind of going between. But what I think is go ahead, sorry.
Oh, I was just going to say, and since it's MIDI, not OSC, right? That controller is going to go from 0 to 127, so it's going to be a set number of steps. So I wonder if you were to smooth that a little bit, if you could make it sound a little bit better.
You want me to smooth this right in here?
Yeah, I'd like, but a very short smooth, right? Because if you're using MIDI data, it's going to jump, across those 127, 128 steps.
So how long should we smooth for?
Yeah, like 10 milliseconds, a millisecond. 10 milliseconds seems reasonable.
10 milliseconds. Let's try it.
That's interesting. What's the difference? I might ask you a question you don't know here. I've never used Smooth 4. I always use Smooth. What's the difference?
With Smooth 4, we can set how long. If I just wrote Smooth there.
Well, if you wrote Smooth with an ED,
yeah,
that's just what someone in the chat probably knows better than I do. But it's like 200 milliseconds, 100 milliseconds. But Smooth : no ED.
Oh, like this?
I don't know what the difference between that and Smooth 4 is. And maybe I'll make that my homework for next time.
Let's see. Continuous interpolation from the previous value to the current value. Smooth 4. It looks like it's the same thing.
It might be the same thing. I think it's
just maybe just updated syntax, slightly more preferable, good form. I don't think it.
Some of my Kyma chops are predate Kyma 7, so
there you go.
That doesn't mean I'm very good at it. That just means I've been doing it a long time.
I'm in the same boat. All right, let's check it out now.
Morphing. Morphing.
I think it It sounded good. I mean, it's still subject to my variations in the way I'm doing this, which we could even do. We could put some Cappy Talk arrhythmic in there, arithmetic.
But I might be doing what already saying what you're going to next. But you can do those independently too, right?
Yeah, we could.
Oh, but you're doing something more interesting.
I was just going to put a ramp in here, which is going to go from 0 to 1. So 1 ramp, I'll do it for the same duration as on duration.
And we don't need that smooth for it since we're doing the ramp, right?
Let's lose that.
Because the ramp itself is smooth. The reason we had that smooth is because it was trying to smooth out the MIDI resolution.
So now, over the course of 2 seconds, we're going to go from 0 to 1, which will take us from the C morph spectrum to the sticky plastic tube. And it's consistent. It'll be consistent, basically. It's not subject to my hand on the fader.
Morphing.
Better? Maybe. I don't know. It's nice to perform it sometimes. Or even like map it to a keyboard and perform it that way. We won't necessarily get into that, but it's kind of cool.
And since you use ramp, it just does it. It was just do it one time.
Right.
But if you did a repeating ramp, then each time it went through the sample. And since your ramp is 2 seconds and your duration is 2 seconds, it would just keep going.
Right. So I could do repeating ramp 2 seconds. Loop is checked, so it will just keep looping. On duration 2 seconds. So let's check this out.
Morphing. Morphing. Morphing.
And in theory, that should be exactly the same every time, right?
Morphing.
I believe so, yeah. Because it resets on the loop, right? All right, let's try. We're honing in on this, but let's see what happens with time index. If I check control time, now we don't use on duration, and we can go right into the timex, and we can kind of scrub the spectrum. So a lot of different things, but you had a cool expression you were showing me earlier, and we can also hang on a point in time here, which I think is kind of interesting.
Yeah, well, I mean, if you want to show this first, then I'll show that expression because it sort of builds on what this one does. So the ramp's still going there. It's still doing the morph ramp.
You're right. So we should, what should we put there?
We could isolate, we could skip the morphing. If you just put 0 in each of those, we'll just hear the morphing sound, right? But if we can bring the morphing stuff back later, but
cool. So
right now we should just have the morphing spectrum in there because we've got both the pitch and the decibels at 0, which is that top spectrum in there.
Let's check it out. And right now I'm reading through it backwards, right?
Morphing. Morphing.
Yeah, so we're hanging on one little spot when the fader's not moving.
So the important thing about this index is that it's -1 to 1. And that's why in that expression that they have in there right now, it's index, right? It's a fader that goes from 0 to 1 times 2, so 0 to 2 minus 1, and that gets it to be -1 to 1, right?
Exactly.
Sometimes I'll just take out that expression and go to the VCS and make that go from -1 to 1 instead. Yep. But okay, so from there we're sliding from -1 to 1. I'm gonna share this thing. Let's see if I can do this. I practiced this. Whoops, where'd it go? Select window or screen. Oh, hold on a second.
Yeah, take your time.
Here, tell a joke or something.
We have a comment from our good friend Simon Smith in the comments. It
Oh,
says,
okay.
he was late to the party, liking it so far, guys. Thanks, Simon. Thanks for tuning.
Thank you.
Thanks for tuning in. I was really nervous. There's a lot happening on the back end here, on top of the complexity of SumOfSines. So it seems to be going all right.
Okay, give me a sec here. I think I failed to do this. Hold on a sec. Have I disappeared from the screen yet?
You have not.
Okay. Let me see if there's a more clever way for me to get this to you. Because it's not letting me. Let's see if that
Oh,
works.
there you go. You disappeared.
Thank goodness. All right, I'm back now, right?
You're back now.
Okay, it's not letting me share, so I'm going to do this in an embarrassing way. I can just read this to you then, right?
Yeah. Just read it to me. What do you got?
So let's open parentheses, index with an exclamation point, and then plus open parentheses 0.1 seconds, so 0.1 s, random, times 0.01, close parentheses, smooth colon 0.1 seconds, and then close parentheses, times 2 minus 1. That was far less painless
Yeah, we
than
should
I
have done
thought
that.
it was. I should have just
start.
done that rather than messing around. I apologize. We
No worries.
so if you allow me to talk through this, what's new about this from what we had in there before? So before we had the exclamation point index times 2 minus 1. So what I've added here is something that chooses a random number every 0.1 seconds, and it takes that random number, multiplies it by 0.01, right? So it's a very, very small little adjustment there. And then I've taken that little adjustment, and I've done the smooth again, and we've probably discovered today that smooth and smooth 4 do the same thing, right? But what that means is now when we're not moving that fader, we're still going to get a little bit of action, a little bit of energy going on. And so it makes it sort of interesting to perform. And then, if you're moving a slider and then you sort of stop somewhere, you don't get this sort of instant, like frozen sound. You're still going to get this little jitter of the time moving up and down by, 0.01 percent of the length. I think percent.
It's cool.
That's probably not right. That's not a right way to say it. It's not percent.
Yeah, it's basically just a little bit of randomness from negative 0.01 to 1.
Right.
Plus wherever the fader is.
Exactly. And it's added to that index, which is the variable, right? The exclamation point index. That's where you have the slider set.
Let's check it out. So we can hear even without this moving.
Yeah. So this is the F part. So this is one of the quieter parts. But if you go to one of the ends,
Thing.
and maybe that's too fast for your taste. Okay, well then you could just increase the time that it takes between them. Or if it's too extreme, you reduce that 0.01. Again, these are the things that is going to be different for each sample, and you're going to want to find that adjustment that gives you the musical results that you want.
Exactly. I mean, let's hear it if we switch over to the sticky tube, right? Now we're in sticky plastic tube spectrum. And now we're kind of can navigate to where it's really interesting.
And also imagine, let's say you do 3 of these on the same sample, right? And they've all got that little random jitter to them. That they're bouncing back and forth across the timeline. And then you pan them to different locations. You can make these really sort of expansive sounds out of your single spectral analysis too.
It's fascinating. Basically there's a world of options, and I think you have to kind of understand what they are, and then you go in and you hone in on what you want to happen. What do you have anything else you want to say about that?
I was just going to point out that, you know, so even though we have these hot variables below for for the loop start and the loop end, though we're not seeing those because we've checked that control time.
Right.
So if we uncheck them, that control time, they come back.
Totally.
But since we're not doing the looping anymore.
No, it's a good point. It's basically, yeah, when control time is checked, we're now using the time index. When it's unchecked, we have on duration, and it also brings into factor loop start, loop end. Right?
Yep.
One thing that's interesting, and I think we've covered a lot, but I did just want to mention the number of partials. So right now we're doing the entire spectrum, because we had 124, right? And we're saying we can have 128 here. But if I went so we can hear it, if we went some like super low, we can hear. I think it's interesting to only have. You know, only hear that much of it.
And I sometimes use this for, again, just sort of generating a bass, right? And if you just want, you know, one sine wave in your bass, you can just put one partial there.
Right. We could just hear the fundamental, right? So now we're only hearing the fundamental of morphing.
Right.
Only the first oscillator in the resynthesis on the.
And of course, that interval slider would bring the pitch up and down again, controlling that independently from the time too.
Yeah, and this is even. It's only set up for the morphing, but we can go in there and.
And again, set it to 120 seconds.
Yeah, but what's cool is right now we're lowering the pitch without lengthening the sound.
Yeah.
So, yeah, then we lengthen our on duration, and Simon's happy, and we're good.
So, but with that number of partials too, you know, I think this is less of a concern nowadays, but back when I was using capybaras a long time ago, if you have multiple tracks of these going, you can't have them. Whoops, did I freeze there? Oh, there we go. If we have multiple tracks of these going, you can't have them all going at 128. You have to reduce the number of partials, and then you got to figure out, well, where am I actually starting to lose sound too? But now with Bacaranas, and if you've got your wormhole set up, maybe that's not as much of a concern.
Totally, yeah. Back in the day, there was more consideration for processing power, definitely. Nowadays,
but there's no point. I should say, but you can crank that up to like 256, but there's no point in doing that if you don't have a spectrum that has the partials that go up that high.
Exactly. Yeah, you're just, I guess, eating DSP. I don't even know if it would kind of tries to calculate that or just forgets it.
I don't know the answer to that, because I guess it's maximum, but I don't know what it does if they're unused. I'm sure it's probably clever enough to not use the DSP, but it's just conceptually good to know you're not doing anything.
Right. I mean, it says the more partials you request, the more computation this algorithm requires. But yeah, I would figure. I'm not sure why you would just do that just to do it, but
I mean, it might have to reserve. I just don't know. I don't know the answer. That's a question for someone smarter than us, I think.
All right, cool. Well, I think we've gone a pretty good overview here. I mean, I could talk about this stuff all day, but I think I'm happy. I don't know if you have anything you want to add.
I think this is great.
Good. Looks like
the exciting thing for people getting started is you can just you record your own sample, and then you have your own analysis, and then you can start building completely original stuff instantly. And so I think this is a really good place for people to get started and do some really interesting sound design in Kyma.
Yeah, well said. I'll second everything you said there. Well, cool. Let's let it
Hey.
go at that. Thanks so much, Simon, for joining me. And
Thanks. I hope I didn't talk too
No,
much.
no, it
That's
was-
always my concern.
no, it was awesome. Simon has a
I had a
great
ball.
Simon has a great YouTube channel, everybody, and it's in the description. There are specifics to other things as well you might be interested in. Feel free to leave questions or comments down below, and we'll see you in the next one. Thanks,
Yeah,
everyone.
Thanks for having me.
All right, thanks. Take care.